Why are we so fascinated with rings? Rings are sometimes worn for ornamental purposes, sometimes as a sign of commitment, and sometimes as a source of power to conquer all of Middle-earth. For planets, however, things are quite different. There have been several foundational theories surrounding planetary rings regarding their formation, composition, and general distance from the planetary body they encircle. But the discovery of the ring surrounding the dwarf planet Quaoar threatens to change everything we thought we knew about rings in our solar system. Want to know how? Join us as we take an unexpected journey to the Kuiper belt to demystify this one ring. It promises to be thought-provoking. Whether you are a veteran space enthusiast or you aren't even really that interested in space at all, you must have seen at least one or two pictures of Saturn. Yes, the one with the pretty rings around it. Why are you able to picture it so easily in your mind? Well, to put it simply, there is certainly nothing like it on Earth. And for a long time, we thought Saturn was the only planet with a ring system. After much research and more space exploration, we know that every gas giant has a ring or two. The rings of these ringed planets are not only mystical in appearance, but they are also complicated, and can sometimes be puzzling even to astrophysicists. A ring is made up of an enormous number of particles, ranging in size from a mere grain of salt all the way up to a small mountain. And each of these billions of particles behaves like a tiny moon orbiting the planet. There are two fundamental theories as to how such rings are created. The first, let's call it the breakdown theory, contends that the rings are the fragments of comets, asteroids, and even moons that got a little too close to the planet and were ripped apart by its massive gravity. These shattered bits continued to orbit the planet, repetitively smashing into each other until finally organizing themselves into the perfectly circular rings we see today. This theory implies that the rings formed long after the planet they orbit. The second theory, which is now generally less accepted, adopts the opposing viewpoint. It contends that the rings are composed of dust and particles from the early solar system that were never able to form into a moon. This theory implies that the rings are just as old as the planet they orbit. To make planetary rings even more exciting, each planet's rings are a little bit different. For example, the rings around Jupiter are made up of tiny particles of dust. Saturn's are wide, brilliant, and opaque. Uranus has narrow, dark-colored rings, and Neptune's tend to clump together, forming arcs. In the last 40 years, we have gotten up close and personal with the rings of the outer planets via probes like Cassini and Voyagers 1 and 2. And just when we were finally starting to understand the process of ring formation, new data came along to blow our theories wide open. Scientists have just announced the discovery of the most confounding ring yet. One that surrounds Quaoar, a dwarf planet within the Kuiper belt. Quaoar. Here we go with the names again. Can't we get an easy one once in a while, like Tom or Emma? Quaoar gets its name from the place of origin of its discovery. The planet was discovered by American astronomers Chad Trujillo and Michael Brown at the Palomar Observatory in California on June 4, 2002. As per the International Astronomical Union's naming rule for minor planets, Kuiper belt objects are to be named after creation deities. The team decided to research deity names based on Native American mythology local to the Palomar Mountain area where they first spotted Quaoar. The name Quaoar, the creator god of the Tongva people who are native to the area around Los Angeles, was ultimately chosen by the team. Quaoar is the third planetary body that's not designated as an actual planet in our solar system to have been found with a ring around it. The first being Chariklo, the largest of what are known as the Centaur asteroids, orbiting between Saturn and Uranus, and the second being Haumea, another dwarf planet orbiting in the Kuiper belt. Wait a minute, there's so many questions. Firstly, how did scientists even spot these rings on these small planetary bodies that are billions of miles away from the sun? And secondly, if Quaoar isn't the first to be discovered with such a ring, then what makes it so special? Let's first address how you spot such a ring. Stellar occultation. Researchers observed Quaoar as it blocked the light coming from a distant star, much like how you might block out your own view of the moon using your thumb. A stellar occultation occurs when a planet, or any planetary body really, passes squarely in front of a star, allowing telescopes on Earth to momentarily view that planetary body's distinct outline. A stellar occultation in 1977 led to the discovery of the Uranian ring system and the first indication of the Neptunian ring arcs. Apart from an actual spacecraft visit, stellar occultations are the most effective way to accurately describe the size and shape of these far-away objects. Okay, but none of this explains why Quaoar's ring is so puzzling to scientists. You see, Quaoar has a really far-out ring. Seriously, the planet's ring is situated twice as far away from the dwarf planet as what was previously believed to be the maximum mathematical limit at which a ring system could exist. This is known as the Roche limit. The Roche limit is the distance at which one celestial body, held together entirely by its own gravity, would break apart because the tidal forces of a second celestial body outweigh the gravitational pull of the first one. Within the Roche limit, the leftover material of that breakup will tend to scatter and form rings due to the continued tidal forces exerted upon it. It is only outside of the Roche limit that a moon can exist, or so it had been thought. This theoretical limit is named after Edouard Roche, a French astronomer who made this calculation for the first time in 1848. The size, shape, and density of the satellite definitely have an impact on this Roche limit, but as a general rule, you can think of it as an imaginary boundary inside of which you get rings and outside of which you get moons. And this theoretical limit really held up for every known ring system we've ever studied in our solar system. Until now. Quaoar is confounding because it is the first example of a ring forming outside of a planet's Roche limit. There are, of course, several theories for this occurrence. According to one theory, the debris forming the ring around Quaoar is less adhesive, which means that pieces within the ring are less likely to coalesce when they collide. Another theory stipulates that the observation team might have caught a snapshot of the ring just before it turned into a moon, although this is a very unlikely scenario. And a third theory proposes that Weywatt, Quaoar's moon, yes, Quaoar has its own moon, might be imparting a gravitational force that helps to keep the ring together. We know, this is totally mind-blowing, universe-altering, astronomical stuff here. But we're not done. There have been other rings making headlines lately. Since its launch, JWST has been shaking things up in the world of astrophysics, and the discovery of this planetary ring around Quaoar that defies the rule of the Roche limit is only one in a string of discoveries that are changing our understanding of the universe. Let's take a look now at JWST's most recent triumph. JWST has already accomplished so much since it was launched, and even on this channel, the telescope has been coming up in our conversations quite a bit. In one of our earlier videos, we described JWST as an exoplanet hunter, seeking out exoplanets with its buddy tests, and even being able to characterize the atmospheres of those exoplanets. And now, JWST has leveled up again and revealed an asteroid in our solar system with rings. The asteroid chariklo. That's the pronunciation we've decided to go with. Think of it like the CH you see in Hanukkah. Chariklo is the largest of what we call the Centaur asteroids and the smallest celestial object in our solar system with rings. It is also the first asteroid to have been discovered with a ring system. With a diameter of about 302 kilometers or 188 miles and orbiting between Saturn and Uranus, Chariklo was discovered in 1997 at the Kitt Peak National Observatory. When the asteroid occulted a star in 2013, researchers used many telescopes to analyze it, and they were beyond shocked to see rings at all, let alone two separate ones. With the data, researchers were able to reconstruct not just the shape and size of the asteroid itself, but also the shape, breadth, orientation, and other characteristics of the recently discovered rings, like the fact that they are estimated to be between 3 and 7 kilometers or 2 to 4 miles wide. Chariklo was involved in another stellar occultation back on October 18, 2022, and JWST was sure not to miss it. The telescope observed dips in the brightness of this distant star as Chariklo blocked its light the same way exoplanets do their stars. JWST observed two sharp dips in the brightness of the star, confirming that the asteroid has a ring system around it. The dips observed by JWST were caused by one side of the ring system passing in front of the star, followed shortly after by the other side. This was a monumental event because it was the first time ever that a space telescope observed a stellar occultation, and the new observational data offered by JWST helped astronomers to clarify the features of this unusual ring system. That just might make JWST the new Lord of the Rings. While there is no definite explanation, scientists believe that the two rings around Chariklo were formed by the remains of debris from a low-speed collision. It's possible that Chariklo collided with a smaller asteroid, releasing debris which was eventually flattened into a disk. There is also a theory that Chariklo might have its very own small shepherd moon, helping to maintain the shape and organization of the rings. Isn't that precious? Back out to the Kuiper belt, we would be remiss not to mention one final ring bearer, and that is Haumea, the very first dwarf planet to be observed with a ring system, even before our curious and confounding Quaoar, back in 2017. To be fair, Haumea is strange in its own right. This football-shaped planet is about the same size as Pluto and takes 285 Earth years to orbit the Sun. Its weird shape is thought to be due to its exceedingly quick rotation. It takes only about 4 hours for it to rotate once on its own axis, making it one of the fastest rotating objects in our solar system. According to astronomers, Haumea was similar to Pluto in the early solar system in that it was made up of half rock and half water. A massive object may have hit the planet billions of years ago, removing the majority of the surface ice and giving Haumea a sharp spin. In turn, the spin stretched Haumea out into its peculiar form. This collision is thought to have also given Haumea its two moons, which may have formerly been a part of the planet's surface, very similar to how our own moon developed. The fact that Quaoar and Haumea are Kuiper belt objects places them at the forefront of scientific investigation. It is only with recent technological advancements that these far-off, distant objects are even able to be explored. And now with JWST stepping into its role as Ring Lord of the Sky, it is certain that these exciting discoveries will only continue. We hope you enjoyed our Ring trilogy. What Kuiper Belt object do you find most interesting? Let us know in the comments.